Let us proceed our lesson with the motivation, and we will try to understand what is a robot, since here we trying to do new robots, right? What is a robot? What do you think? Can we call a washing machine a robot? Washing machine is a robot?
I think yes. I don't know, because we program it to do something.
What is the difference between robots and mechatronic devices? You know, it's always mechatronics and robotics. What is the difference between mechatronics and robotics? What do you mean by movements? Mechatronic washing machine is able to move. It do not walk, but it's able to move.
Robotics, we can manipulate their tasks. We can program them, or
You can program your washing machine with the different scenarios.
I think the purpose, because the robots can do different tasks, depends on what you program.
It's it's a good idea that the difference between mechatronic devices and robots in intelligence. The robot is supposed to be more intelligent than a mechatronic device. Washing machine is purely a mechatronic device because it has mechanics, it has electronics, and has control loops. They pretty simple, but still we have them. And by a robot we mean something more intellectual. It's something which is able to operate maybe in unstructured environment. It's able to plan its own trajectory, and in this sense a robot manipulator that is used in industry for just painting or welding, it's not actually a robot. It's a mechatronic device that just move along a predefined trajectory.
can I ask a question?
Sure.
For example, if the washing machine
Mm-hmm.
can be able to identify the clothes.
Yeah, I think that after that we can call it a robot. Yeah, sure. But and just an industrial robot manipulator, not the one that just showed in the picture, but a huge one that used in car manufacturing. It's not actually robots. Those are just mechatronic devices that do simple motion. All right. But it's something that we can argue. You know, there is no strict definitions. But in order to make some line between robots and mechatronic devices, robots is something which is more intellectual. So, and robots, just like mechatronic devices, they do some mechanical motion in order to transform motion, maybe to transform energy, information, or material, I don't know, instead of human, to make humans' lives easier. And it contains robotics, just like mechatronics. It's a multidisciplinary branch of science. It contains a lot of different topics, such as electronics, mechanics, learning, programming, and so on, so everything. And our task as roboticists is to contrive new robots, because there is no point to create old robots, right? For a given purpose. And if we want to create a new robot for a specific purpose, we need to make sure that we create all parts of these robots or mechatronic devices, like mechanics, drives, electronics, and software, with respect to each other, because the performance and behavior of a robot or mechatronic device depends on each of these parts, right? And how can we do this? We can use simulation in order to achieve this. Because in the simulation we able to to create a one huge model that consists of a lot of different parts from different physical domains. And actually, we will try to do this during our practice and projects. So here you can see an industrial robot, actually. So it's not a robot, it's a mechatronic device. But still we can see that it's pretty complex system that consists of mechanics, electronics, controls, sensorics, and we actually can say that it is complex system. Complex, it means that it consists of a lot of different systems, parts, subsystems, sub-models, and to create a new one, it's pretty damn difficult. And if we will take a look at the guidelines of designing new robots, there is no like a strict guidelines to create a new robot. And we can say that it's yes, it's still a science, but also it's like kind of art rather than just science, because it fundamentally not formulated. There is no strict directions how to do the synthesis and design of new robot, and you need to do a lot of different choices during your design. For example, you want to create a robot for specific purposes. I don't know, you want to create a galloping robot, you need to think about morphology. How many legs do you need? One, it will be hopping robot, maybe two, biped, maybe you need to implement four legs, or maybe you need three, I don't know, maybe. Then you need to do to think about mechanics, how many degrees of freedom you need, how many, what kind of joints you need. Then you need to go deeper in the details and think about parameters, materials, the way how can you actuate it and manufacture it. And after that you will finally have some design, and you can simulate it in order to get numbers that will give you understanding how your system performs, how it behaves. And after that, you can use optimization techniques to tune your parameters if the result is not good enough. You can iterate with the detailed design, with mechanics, morphology, and the iteration can be like infinite. It depends on how much time do you have, and what about the resources, and still your result will be not optimal but suboptimal. All right, so finally, why do we need modeling? And by modeling I mean analytical modeling and simulation also. We needed to just study a system, how a system behaves, a system that already exists, or maybe something that you want to create. You have some kind of hypothesis and you want to study it. You want to predict how your system will behave. You want to use it in order to optimize, such as your system will behave better. To steer it, I mean to control it, just to know how it works and finally to make it better. It's like, why do we actually use these techniques? All right, so it was the motivation.